Okay, so welcome to the June 18 OpenGenI community call. The purpose of this call is to talk about our recent releases, so 0.44 and 0.45. So I'll do a brief summary of what happened. So 0.44 was released May 28th. This is the second quarter refresh for OpenJDK 8, 11, 17, and 21. And 0.45 was released on the 21st. And that's the JDK22 release. So there are a few changes in this release, in the 0.44 release, that is. A lot of them also made it into 0.45. I won't talk about everything because we're going to have presentations by a few people to discuss these in detail, but I'll highlight some of the changes. So JCommand now supports specifying the application name along with the VM ID when sending JCommand operations. So this is a new change. This means that you don't actually have to list out all the available VMs on the machine. If you know the name of the application, you can send a command with just one command. There are some DDR updates and some other updates to attach API, but yeah, those were the few I wanted to highlight. So yeah, let's go ahead and start with the presentations. So why don't we start with Long U?
Sure, I will share my screen. Not sure if I'm sharing the correct screen for the presentations.
You are sharing your Chrome.
So probably I can share another one. Okay, here it is correct. So good day everyone. So I will talk about the QA features during our OpenJ9 release. So first thing is the test.env.property file .properties. So during the release, we tag all the repos and the branches, and then in the release, we will have a summary of all the repos and the branches we used for our release. So in both the release pipeline and in the personal grinders, we will have an option called use test env properties. So when we check these parameters, then we will just use the test env properties repo and branches in these files. This file it is under the adopting aqua tests repo and in the folder of test dot properties. So something we newly added for this release is the OpenJCE plus Git repo and Git branch. In this way, we will have more controls of all the repos and the branches. Something I would like to mention is that regarding this testinv.properties files, besides the previously just work with Jenkins, so currently it also works in our container-based testing. So when we check these parameters in Jenkins, then in the container environment, it will pass these parameters into the container environment to also use those repos and branches for testing. So some general enhancement is we added several tests like Mockito tests, crypto test, GTRAC, minimix terminates, and also updated the example functional tests to sanity levels. Also regarding the pipeline, we changed several settings like outset the lightweight checkout and generate jobs. And also for the Aqua test pipelines, we set several parameters to be dynamically generated, so we don't need to set a bunch of parameters. And also, if the SDK resources not customized, then we will onset the customized SDK URL. This is a fix for the Jenkins pipelines. So for some other enhancement, we removed the version checks for the external test for. So when we add the new JDK versions like JDK22, 23, we don't need to manually enter the numbers into the allow list, and we also use the vendor repo materials for the update of the test materials. Also, we updated the custom URL to dynamically use the Jenkins domains to detect if it's HYC Jenkins or it's adopting Jenkins. And also for the type file collections for Aquavit verifications, we added the function of check field test and type file for it. And also we updated the lambda for smoke tests path. In this way, it will be able to use the pre-staged dependencies in case the network was not stable during release. And also we and some enhancements for CRU and FIPS. So for CRU, we added the container-based functional tests, so we can run more functional tests regarding CRU, like the random checkpoint tests inside of the container environment. And we added the CRU functional softMX tests. Also, we removed the TMPFS settings for the container because this is not needed. Also, we updated the doc files for the pinperf test for JDK21, and we updated the CRU versions, and also updated the settings of the configure AMD GPUs. So for FIPS, we ended the OpenGC Plus tests, and also we ended the support of OpenGC Plus Git repo and Git branch. Besides the test.env.property files I just mentioned, we also support the settings of this one in Jenkins environment. Also, we ended the FIPS specific test target Java XNet SSL FIPS as the placeholders for FIPS test. Also, we undid several dependencies for it and updated the flags to support the 143 FIPS. So some more enhancement of TKG and TRSS. So for TKG, we allow the setting of TKG repos and branches in the get dependencies. So this pipeline it was used to get the dependencies we need before we run the test. And also we added the support of spaces for vendor names when we put it into one we put so when we put the vendor names, we will be able to add the spaces instead of instead of just put all the names after each of the comma. So we undid the check of Podman and Maven version checks on the host machines, so we can be aware of the host environment we are using. And also we undid several dependencies in the TKG for OpenGC plus test, Mockito test, and undid support for the CRAC feature. Also, we undid the limit overall test case summary for all targets with GTREG. And for TRSS, we did several enhancements, including support of advanced search across builds, and also added the API to rescan the build. And also, we added the function of open Git issues and open J9 reports. Previously, we can just open it and acquire test report. So currently, once the input is open J9, we'll be able to open the Git issues and open J9. And also we use the promise.out to better handle asynchronous operations. Also, we fixed the loading of paginations and also undid the lazy load so people can view the website more quickly. That is all from me. Any questions? If no questions, I will pass it back to Toby. Thank
All
you.
right, thanks, Longy, for the presentation. Okay, so next up we have Babneet for JDK22 updates.
Maybe can you see the slide?
Yeah, it looks good.
Okay. So JDK22 introduced a variety of new features aimed to improve developer experience, streamline concurrency, and enhance performance. Here is the list of the features or JEPs which were added to JDK22. A few of them, if I were to cover, are like statements before super previously. Code execution within a constructor had to occur after the superclass constructor call. And in JDK22, we allow these statements before the super call, which provides more flexibility for initializing objects within constructors. Another good one is unnamed variables and patterns, which addresses the issue of unused parameters and variables by allowing developers to declare them without resorting to dummy names. And I think the list goes on. The OpenJDK link shown below on the slide is a good reference point to learn more about each JEP. And OpenJ9 specific work that was done for JDK22. I think work was done for virtual threads and foreign function and memory API. Tracking Jack and Cheng will cover them individually later. So the things which need to be covered are method handle improvements. So in JDK22, an optimization went in for method handle proxies as interface instance, which creates a method handle for a single interface instance method. So this function was re-implemented using a more direct method handle approach to improve performance. And what happened was it introduced hidden classes which have an interface as your host class. We didn't have support for this in an OpenJ9, so we ended up adding support for this new kind of hidden class. And more issues started happening because these hidden classes are short-lived, so GC would collect them, leading to stale references. So more work was done to make sure relationships between these hidden classes and their modules were correctly maintained in the VM. Then Xdebug and debug options were deprecated, and I think if they are used, then a warning message will be printed by the JVM. And then there were miscellaneous bug fixes in existing features which showed up because new testing was introduced in the extension repo or the OpenJDK test suite. And so we ended up fixing all of them for JDK22. And I think this sums up my update for JDK22.
Right,
So if
thanks,
there are,
Babneet.
yep.
Yeah, does anyone have any questions on any of the work that went to JDK22? Okay, if not, thanks, Babneet, and we'll move on to the next topic. So I believe it is Jack for Loom updates.
I'll just share my screen. Wait. Can everyone see my screen?
Yeah.
Okay, so for Project Loom, as Bethany have mentioned, it included mostly three JEPs, virtual thread, structure concurrency, and scope values. To start, we'll start with the virtual threads update. So in this release, we have added a new XX option, show unmounted thread stacks. This will allow the display of virtual and carrier stack traces in the Java core that are unmounted, which don't associate with a native VM thread. This option currently is disabled by default just because in the nature of virtual thread, there could be millions of unmounted threads that are not running, and having it enabled all the time in Java core will be very verbose for the output, and most of the cases, the unmounted thread stacks, because they're not executing, they will not cause any errors to the underlying VM before they can be remounted back and start executing. However, it is a useful option to debug and look at particular thread stack and see the state of the thread in to determine whether it is blocking other threads from running based on how their execution cycle is. The second one is the update to virtual thread state. The runnable state have been removed in JDK22. Instead, it was the two states that was added, which is unparked and yielded. What it does is yielded means that instead of just being runnable, what yielded means is yielded is when a thread has been voluntarily yielded from the carrier thread, however, it is rescheduled already, which guarantees it will be run. While unparked means that it have been parked before, but currently is unparked. However, there's no guarantee that this is actually being scheduled unless there's additional code either on the user side or on the virtual thread side that will reschedule it back to the scheduler. So it sort of refines the state a bit more. This also impacted JVM TI because all the JVM TI APIs would now have to handle the two new added states. And given that runnable has been removed, all the numbering of the state have been shifted to account for the removed state. Lastly, there's a JDK trace pin thread API that was added in order to help user identify potential bottlenecks and log contention issues with thread pinning. This has been replaced with JFR for JDK22 and beyond, which we currently don't support yet. So if you're looking to use this feature, I suggest starting with JDK21 at the moment. And lastly, there's an updated synchronization for suspend resume of virtual thread under JVM TI API calls. There's also additional support we've done to support some extension APIs in JVM TI which are not standard. So currently there should be no issues with the suspend resume of virtual thread with any of the locks and deadlock and potentially live lock that we've seen before. So moving on to structure concurrency and scope values. The preview continues with exactly the same user level API between JDK21 and 22, with minor updates in the JCL source code that have been done to enhance performance and remove some of the duplicate code and make them into common API. But from a user's perspective, there should be no differences that are being seen. And that's it for Loom update. Any questions?
Yeah, I just had one question, Jack. For the show unmounted thread stacks, can you comment on how one would generate a Java core where you had more guarantee about showing all the unmounted thread stacks? Specifically, what we need to do to track all the unmounted virtual thread stacks and what other options we can add to give us more guarantees that we will find them.
Okay. So currently, what show unmounted thread stack does is it will iterate through the list that is currently maintained by GC of all the continuation object, which is the underlying data part for a virtual thread. In order to guarantee that the virtual thread stacks unmounted ones that you're actually displaying in the Java core are correct and up to date, it's recommended that the Java dump option be used with exclusive access. And potentially we could also force a GC and before the dump actually occurs. This way it forces GC to update the list and remove any of the dead virtual threads from the list so that you will not be hit with excess amount of threads. But the most important part is just to make sure that when the dump agent is running, it's running exclusively, so there's no GC operations being done in the backend, which could potentially invalidate some of the thread stack that's being printed.
Before we leave this, there's two comments. Runnable has two ends, but can you clarify what you mean by removed? Thread.state still has an enum member called runnable in 22 and the headstream. So what do you mean by removed?
Sorry. So runnable state is part of virtual thread state, which is not part of the standard Java Lang thread. So what I meant by runnable was that the runnable state in virtual threads enum has been removed.
Well, virtual thread doesn't have a nested member called state.
It's a virtual thread state. It exists in the JVMTI API, and it's also part of a sorry, I don't have it on top of my head.
Virtual thread.java. It's part of virtual thread.java. There's a field named state, and
Okay. So I thought we were talking about the sort of the public API of a virtual thread. So if you ask, if you call the, I don't know if it's get state or just state, it answers a state object. And or sorry, the thread state is a package private thing. So how does this what's the user level view of this change that you've highlighted here?
So for virtual thread state, this one would only impact JVMTI. So if the user calls virtual thread state through JVMTI APIs, they will be able to access the raw state that's stored in the virtual thread object instead of the mapped Java Lang thread state that they will get from the standard Java API.
Okay, thank you.
All right, if there are no further questions, we'll move on to the next presentation. So thanks, Jack, for the Loom update. Next up is Henry for a JIT update.
Okay. All right, so for the JIT, some of the things that have gone on for the 0.44 release are situations where implementation of things in Java class libraries, for instance, have changed a little bit, and so the JIT needs to be able to handle those altered scenarios. So, for instance, there were changes in the way there are situations that the JIT recognized for where Java class libraries were encoding values, string values in byte arrays if they were ASCII values, and how that was done in Java 11 and prior used a certain set of APIs. Those now a different set of APIs are being used. So just to maintain consistent performance for those things, the JIT needs to be able to recognize the new APIs that are being used for that scenario. So in addition, there have been some other string performance enhancements for string index of. Again, that was a situation where the underlying implementation changed a little bit, and so the JIT is now recognizing for Java 17 and later the new implementation of string index of to give performance that's on par with earlier versions of the JDK level. And finally, for var handles, so with the way var handles are implemented in OpenJ9 for Java 17 and later is different than the way it was handled in previous versions. So on top of that, there's more and more uses of var handles that are being made in Java class libraries and in Java code in general. So there's a specific emphasis that was made on being able to inline some of the call chains that happen for var handles to get better performance out of them, and that's this particular item that's mentioned here is sort of a work in progress. So this improves some of the performance, but we're expecting further performance improvements with var handles in the 0.46 release coming up. Then on top of that, there have been various improvements that have happened that are sort of architecture specific. So for instance, for AArch64, there were opportunities for recognized for string index of and string hash code, where the implementations of those, the code generated for them, can use vector instructions to get better performance for those operations. Similarly, for Z architecture, there's an opportunity recognized for array comparisons. So this is something that had actually happened earlier on other platforms, where the JIT will, if it notices that the start addresses of two arrays are the same for an array comparison operation, it automatically indicates that it short circuits the comparison and just says, yes, the two values are the same, rather than going through the trouble of actually comparing all the elements that are to be compared. But so that was something that was previously done for AArch64 Power x86, but it hadn't been done for Z or Z because the additional complexity on that platform for how array comparisons are performed, there are all sorts of cases that have to be handled based on the possible lengths of the operands and things like that. So there was a lot of additional complexity. So that has just made it into 0.44, that improvement for Z. And then besides actual runtime improvements for the JIT compiler, there have been some ongoing tuning efforts for compile time performance. So trying to improve the compile time in situations where compile time is recognized to be an important thing, like at startup time or for Xtune virtualized. So there are a few improvements that have been made there. One is to do with the tuning of inlining for very large methods. So adjusting how much inlining happens for such very large methods if compile time is an important consideration. And further tuning of the level of optimization that's performed for some I guess one particular one was loop versioner optimization, recognizing situations where it was more important to get compile time, a faster compile time than the potential runtime performance benefit that might be realized from loop versioning. And then besides compile time and runtime performance changes, there are always ongoing defect fixes going on in the JIT compiler. One of the most important ones that happened with this the 0.44 release was with the loop versioning optimization. There was a large effort with many thousands of tests, generated tests run to recognize situations where inside of a loop an array index might go out of bounds. So being able to determine that before executing a loop, and being able to determine that array indices will never go out of bounds provides the opportunity to avoid checking those array bounds within the loop. So there was a very large amount of work that was put into being able to detect before a loop is executed, whether array bounds could possibly go, whether array indices could possibly go out of bounds, and then actually, forcing the checks to happen inside of the loop versus recognizing when the array indices will not go out of bound, and being able to just do that check up front before a loop is actually executed with a one-time check. So that was a big robustness improvement. This is an optimization that's long existed in the JIT compiler, but making sure that this was fully robust. And that's it for the JIT. Any questions?
All right. Thanks, Henry.
Thank you.
We'll go to Hung for share class cache updates.
Can you guys see my screen?
Yes, I can see screen.
Yeah, so I'm going to talk about what's new about share class cache in this release. So the major changes support for jar index. So jar index is a text file called index.list in a meta-info directory. So it has the list of packages defined in each jar used in your application. So it's an optimization for class loading. So class loader does not need to actually open each jar on the class file on the class path to search for the class. It just needs to go through the jar index to determine which particular jar contains the package to be loaded. So it needs to open that jar to load the class. So if there's a jar index in the application, the class path attribute in the jar files manifest is ignored. So the jar index is a feature in OpenJDK. So the OpenJDK, we patched the Java class library code in the extension repo to work with the OpenJDK's share class feature, and the patch always respect class path attributes. So which means that when you have a jar index and a class path attribute in your jar file, those two may contain different informations. So possibly it'll result in different class paths used by the URL class loader. So in this way, it's possible that you will notice inconsistent class loading behavior when share class cache is turned on versus share class cache is turned off. So we have users seeing class loading errors and exceptions when they have a jar index in the jar, and the jar index has different class paths than the actual class path attribute in the jar file. So for this release, we have added the jar index support in our shared class GSAO patch. So in this way, you always get the consistent class loading behavior functional behavior when you turn on share class or turn off share class. So that's the only major change in this release. One thing I need to mention is that the support is added only in Java 8, 11, and 17, because the jar index feature itself is dropped in Java 21 by OpenJDK. So we're not adding this to Java 21. So that's everything from me. Does anyone has any questions?
Yeah, do you know why the jar index feature was dropped in 21? Is there like a replacement for it, or?
No, there's no replacement for that. There are long-standing issue about jar index because people can update the jar index without updating actually the packages in the jar, or updating the jar only without updating the jar index, which will cause problems in the runtime. So there are other complaints about this feature in OpenJDK, so they eventually decided to drop that.
Okay. All right. Thanks, Hung. Any other questions for Hung? All right. Thanks, Hong. I will move on to FFM with Cheng.
Yeah. Yeah, here's the screen. Bobby?
Yeah, I can see your screen.
Okay,
You-
cool.
Yeah, looks good.
In Java 22, the JAP 454 is the final version of the FFM, which means there's no more FFI specific changes proposed through the JAP, except the bug fixing in the future. I just highlight all the features changes implemented in this JAP. From OpenGNI perspective, the main change is passing in the heap argument in Danko, which is already supported in OpenGNI. The rest of the changes happens in OpenJDK, so which includes a couple of adjustments of the existing APIs for the better user experience. I'll go through quickly to see what it looks like and what's the difference from Java 21. So a heap argument is specially designed in OpenJDK to enable users to manipulate memory segment on the heap, which is controlled by the garbage collection. If you want to create a heap argument in your application, you just call the memory segment of array, which is kind of a piece of segment from a heap. And you must specify link options to use a heap argument in native. In Java 21, we have linker options called is trivial to support the critical operations in Danko, which means it must have a extremely short time, and there's no opcode, no zone opcode allowed from native. In Java 22, the same rules still apply to this type of code, this type of Danko, but the method name changed to critical, and you must specify the heap access flag to enable the access in Danko. So this is something different from Java 21 for this API. This is an example of how a heap argument is passed to the native through the Danko handler. Naturally, there's no big changes as compared to our type of Dankos, except those heap argument specific method on flags. There's one thing to note, because there's no garbage collection activity during the Danko when accessing the heap argument in native, because the heap argument will be messed up if the GC is still working on it and to update the object on the heap. But so you don't have to worry about anything out there because everything is already supported in OpenGNI. This example, this command line options enable native access has been already out there for a long while to enable the restricted methods used by the code in modules without a warning. But this approach is too generic. So it's better to do that in a separate way for the executable Java files. Starting from Java 22, a new manifest attribute has been introduced to do the job for the Java files. The new attribute comes with pretty much the same name as command line options, but with a capitalized letter, and only one value set for all the modules. So you don't have to specify the command line options in the meantime when running the executable Java files. Before the Java 22, there's no easy way to access the struct with a variable length arrays through the while handle or the method handle combinations. To solve the problem in Java 22, a new method called scale is added to memory layout. The idea is that to return the sum of the offset plus the layout by size multiplied by the layout index. This is to simplify the computing the base object, which is used by the var handle, a slice handle, and by offset handles when access this type of struct. And a scale handler is just a method handle to evoke the scale method. Canonic layouts is a new method added to linker in Java22 to offer a way of proving the primitive layouts supported on a given platform. Laterally, it's composed by a bunch of map entries like what I list here, which means you can see what primitive layouts are supported on your platform, but you cannot change any of them. This is why this method is most used internally in GCL, in JDK. The last one is about the changes with the char sets for native strings. In Java 21, there's only two methods, get and set UFA strings to access the strings and native. And it must be UFA 8 and no other standard encoding mode is supported, which is kind of limitations when users are working on a non-UFA platform. So in Java 22, a bunch of fixed size standard encoding modes are added to the char set to provide users with an option to specify the encoding mode to convert native string as required on their platforms. And the previous methods in Java 21 are replaced with get or set strings to enable the flexibility for users. What if the encoding mode on your platform is not non-standard? If that case, you better check out through char set for name to see whether it's supported in the JDK or not. Because these non-standard encoding mode are not documented in the public APIs, but might be implemented in the JDK. So you have to make sure the encoding mode is ready up there for use. Yeah, that's about it for FM in Java 22. Any questions? Okay, back to topic.
All right, thanks, Chang. Yeah, so for the final presentation, I'll just do a quick update on CRU support. All right. So CRU, that's checkpoint restore in user space. It's an API that we've offered for some time now that allows a user to take a checkpoint and resume it at a later time on a different machine. The primary use for this API is for startup enhancements. So the idea is you take the checkpoint during the build phase, and then you restore it at deployment. And the restore is going to be much faster than a conventional startup. So we've had this feature in preview in OpenJ9 for quite some time, I think back as 2022. It's being used in Open Liberty, and that the branded name for that is Liberty Instant On, and so that has been GA'd. So at the OpenJ9 level, we support it on all Linux platforms. And at Open Liberty, it's only supported on XP and Z. So some of the key updates this year, some of them were actually in the first quarter release as well, but we have support for restoring with random UIDs. This is just to make it easier for people to adhere to security best practices. We've been adding some support for OpenJDK crack APIs just for compatibility. The APIs themselves internally use the CRU support APIs. There is, in most cases, the mapping is quite natural. CRU support itself is a little more expressive than crack APIs, so that there is nothing, there's no missing aspect there. We haven't fully completed the list of crack APIs. We've added the checkpoints, resource, crack management beans, MX beans. There's some things missing with respect to command line options. So restoring an image using command line options is still pending. And then there's some features with respect to file policies that are missing, but we plan to add those in the coming releases. Additionally, we added support for setting ghost file limits. So this is important. If the JDK is set up to use temporary file-backed virtual memory for this claim. periodic disclaims. So that's an important capability. And we've also added command line support for toggling logging. So that's the verbosity of logging, where logging is outputted to, toggling privilege mode access. So if it's using privileged mode or unprivileged, and whether support for live TCP connections is enabled. Moving forward, the focus is on adding enhanced debugging and diagnostic support. So we already have some diagnostic support for things like xdump, xtrace. We're building that out a bit further so that it works in all cases, whether the method's compiled or not. We also want to enable the ability to attach to a debugger at restore, even if debug capabilities were not requested at checkpoint. So this would mean that you could use a standard deployment image, production image, and attach a debugger to it if there are issues. So these are all things that we're doing to improve ease of use. Today, users don't have to, users can simply add options to an existing image. They don't have to rebuild it. They can use an environment variable to request new capabilities, and we're trying to achieve something similar here. The other thing we're working towards is improving our first response footprint. So we're looking at approaches to disclaim memory at checkpoints. The checkpoint restore barrier is a nice point because there is a phase change between startup and ramp up / steady state. So we believe that there is opportunity here to disclaim some of the memory that is only needed at startup, so that it's not reflected in RSS at ramp up. So yeah, those are the main two things that we're working towards for the remainder of the year. Any questions on that? Okay, so if not, I'm going to stop sharing this and we'll go back to the doc. All right, so we're at the any other business section. So if anyone has any other topics they would like to bring up or discuss right now, we can take the time to do that. Okay, it looks like it's not. So I just want to thank everyone who worked on getting the 0.44 and 45 releases out. Thank everyone for all the PRs, issues that were opened, and all the release and testing efforts. We will have another call in a couple months once we have released the 0.46 release, and then we'll do another one again for the end of year for JDK23 and the Q4 release. So thanks everyone for joining us today, and we'll meet again next time.
Thanks, everyone. And thanks for organizing, Toby.
Bye, guys.
Pleasure.